Good afternoon. In this video, I will be explaining concepts of naive Bayes classifier. So what are classifiers basically? Classifiers allow us to classify different text documents into different classes based on their similarities to the contents of the classes. Basically, classifiers are divided into two classes: generative and discriminative classifiers. Generative and discriminative classifiers can both be used for classification, both can be supervised methods, but the way they go about separating positive from negatives is very different. Generative classifiers would make a model of positive and a model for negative words and basically some characteristics of the entire population. So what type of positives you are likely to see and what kind of positives you are not likely to see, and same for the negatives. Thus it creates boundaries where one model is more likely than the other, and all this is based on probabilities. Thus most of them are probabilistic models. For example, further, a discriminative model approach would determine differences in linguistic models without learning the language and then classify input data. On the other hand, a generative model would learn each language and then classify them using the knowledge. Discriminative classifiers include KNN, decision tree, and SVM algorithms. On the other hand, generative classifiers include naive Bayes and model-based classifiers. Generative models learns joint probability distribution. For example, finding the probability of X and Y. On the other hand, discriminative model learns conditional probability distribution. For example, given Y, what is the probability of X? To explain this further, let's consider the following example of X and Y coordinates, where the first input is 1, 0, second input is 1, 0, third input is 2, 0, and fourth input is 2, 1. For joint probability, you can see the distribution where if X is 1 given and Y is 0, we have a probability of 1 by 2, which is basically a simplification of 2 by 4. For X is equal to 2 and Y equal to 0, we have a probability of 1 by 4, and similar for Y is equal to 1 by 4. Now for conditional probability, we have condition that if Y is equal to 0, 1 would also always be 1. Thus the conditional probability is 1. On the other hand, if Y is 0 and X is 2, then the conditional probability is 1 by 2. And if Y is 1, the conditional probability of X equal to 2 would be 1 by 2. Naive Bayes theorem is based on Bayes theorem, and Bayes theorem describes the probability of an event based on prior knowledge of conditions that might be related to the event. For example, the probability that class, given the data we have, the word we have X, is equal to the probability of classifying the word in class C is based on the probability of X given class C multiplied by the prior probability of class C divided by the evidence that we are dealing with the word X. This is called posterior, whose formula is equal to the likelihood of the word being put in the current class multiplied the prior probability of the class divided by the evidence. Now let's discuss the probabilistic model for discriminative classifiers. To train a discriminative classifiers, all training examples of different classes must be jointly used to make single discriminative classifier. For example, in case of a coin toss, we have two classes, a head and a tail, and only one of those can happen. For classifier of languages, we will have classes of all available languages, and input language will be classified into one of them. For a probabilistic classifier, discriminative classifiers can be divided into two. probabilistic classifiers and non-probabilistic classifiers. For a probabilistic classifier, each class will be given a probability to find whether input is classified in that class or not. Input is classified based on class with highest probability. For a non-probabilistic classifier, we do not label the classes separately and all the classes are labeled single. For example, in this example, if we have a Word document consisting of m words and we can divide, we have to classify them into n classes, the probability would be probability of C given X. Now coming to probabilistic model of generative classifiers, all models are trained independently on only the example, using only the examples of the same class label. For example, if the class is Chinese out of all the linguistic classes, then the model for this generative classifier would, for Chinese class, would be trained on all the examples of documents which are already classified as Chinese. The model outputs n probabilities for a given input with n models, and the model and the class with the highest probability is chosen to be the class to be classified. Now let's discuss the topic of maximum a posterior classification, also known as MAP. For an input consisting of n words in a document, we run the discriminative probabilistic classifier and find class with the largest probability. We assign input X to label with the largest probability. For generative classifier, we use Bayesian rule to convert our formula into posterior probability. In this case, to find we using the Bayesian model where the probability of finding the class C given X is equal to probability of X given class C multiplied by its prior probability of class C divided by probability of the word X. Now since Px would be common for all of the classes, it is common for all the classes and we can thus disregard it from our calculation, considering it as a constant value. Now for naive Bayes formula, we have the probability of C given X is equal to probability of X given C multiplied by probability of C for all the classes, K classes. So the formula is equivalent to the joint probability model as explained below. We have n words in our document and K classes. This can be written as a chain rule as shown in the formula, and we multiply all the conditional probabilities of X with all the X with all the classes and multiply it by the probability of class K. We also make an assumption that all the features in X are mutually independent, conditional on the category CK. Thus, our mentioned assumption lead to the approximation that thus our joint model can be expressed as the summation of probability of Xi given Ck for all words in the document, basically X ranging from 1 to n multiplied by the probability of the specific class Ck. This gives us the probability that the specific word goes in the class Ck or not. To better understand the naive Bayes classification, let's consider a following example. We have data set of 14 days with various conditions of outlook, whether it could be sunny, overcast, or rainy, and temperature could range from mild, hot, and cool. Humidity could be normal or high, and the wind condition could be strong or weak. Based on these conditions, the training data provide us information whether to place tennis or not. Based on the dataset, we can find that the probability of playing tennis is 9 by 14 and the probability of not playing tennis on a specific day is 5 by 14. Now to train our model, we have to train our model based on the original information that we are provided. Based on the information, if the day is sunny, 2 out of 9 days we play tennis and 3 out of 5 days we do not play tennis. And if the day is overcast, 4 out of 9 days we play tennis and 0 out of 5 days we do not play tennis. And if the day is rainy, 3 out of 9 times we play tennis and 2 out of 5 times we do not play tennis. Similarly, for temperature, if the temperature is hot, 2 out of 9 times we play tennis. If the temperature is mild, 4 out of 9 times we play tennis. And if the temperature is cool, 3 out of 9 times we play tennis. On the other hand, if the temperature is hot, 2 out of 5 times we do not play tennis. 2 out of 5 times we do not play tennis with mild condition, and in cool conditions 1 out of 5 times we do not play. Similarly, we can find the same probabilities for humidity and wind conditions. Now after training our classifier, we need to test the quality of our classifier. Now, given one case where outlook is sunny, temperature is cool, it has high humidity and the wind is strong, how would I classify it as whether yes or no? Let's understand it using our formula that we derived earlier. Now, because the outlook is sunny, for outlook sunny, cool, high humidity and strong wind, we understand all the cases where we play yes and we play no and find the probabilities. Now we figure out all these probabilities for play equal to yes and for play equal to no, and for each of those we multiply all of these. For class C given x, we multiply all of those attributes given x is constant, and for class of no, we make x equal to constant and consider all the given attributes. This gives us the following two probabilities, and from the results we can find that the probability of no given x is greater than probability of yes given x. Thus we can classify our input information x as no. So thus, based on the condition, if the outlook is sunny, temperature is cool, humidity is high and wind is strong, we do not play tennis. Let's consider another example where we have symptoms of whether a person has flu or not. This can be deduced based on if the user has chills, has runny nose or not, has a mild, strong or no headache, or whether has a fever or not. Given the data for the symptoms, whether the patient has flu or not, we have to classify based on the given information. The given information specifies that the user has chills, does not have a runny nose, have a mild headache, and also have a fever. Similarly, we find all the probabilities given the user has chills or not, and the user has a flu or not. Same for runny nose, headache, and fever. Finding each of the probabilities given our conditions of x, that the user has flu, the user has chills, does not have a runny nose, has a mild headache, and does have a fever, we classify it with all the classes that we have for yes and no, and we find that the probabilities, and thus we can classify the given information as that the user does not have a flu. Now let's discuss some of the pros and cons of naive Bayes algorithm. Naive Bayes is an easy and fast to predict algorithm to predict the classes of a test dataset. Naive Bayes classifier performs a lot better compared to other models, for example logistic regression, and it also needs less training in data. It performs well in cases of categorical input variable compared to numerical variables. It is highly scalable and it scales linearly with number of predictors and data points. It handles contiguous and discrete datasets and is not sensitive to irrelevant features. Now coming to cons of naive Bayes, if categorical variable has a category, does not have a category in the dataset, which was not observed in the training dataset, then the model will assign a zero probability and will be unable to make any kind of predictions. This is often known as zero frequency. This can be solved by smoothing technique. One example of smoothing technique is Laplace estimation. Naive Bayes makes assumption of independent predictors. In real life, it is often hard to get set of predictors which are completely independent. Naive Bayes algorithm has a lot of applications. Naive Bayes algorithm is fast and thus can be used for making real-time predictions, even in search histories and search results, searching algorithms. It can predict probability of multiple classes of target variables. It can be used for text classification, spam filtering in emails, and sentiment analysis. Naive Bayes and collaborative filtering together can help make recommendation systems to filter unseen information and predict whether user would like a given resource or not.